Greetings to Dr. Ayub and our external evaluator. We're from Group 18 and we will be presenting our PDP2. So our outline starts off from introduction, conceptual design, heat integration, process control, safety, waste treatment, process economics, and conclusion. Our problem statement is to reduce or remove sulfur oxides emission from an existing thermal oxidizer flue gas and also convert it to value-added products. So our three main objectives are to ensure stack gas meets the environmental requirements, reduce SO2 and CO2 emissions from flue gas, and produce two value-added products, which we have selected to be methanol and ammonium sulfate. For reactor selection, we have compared between two reactors, fixed bed and fluidized bed. Fixed bed having a higher conversion, whereas fluidized bed having a better heat recovery. But due to the chemical reaction of CO2 to methanol, that is exothermic, we have decided that fixed bed reactor should be selected, and also because of the reasons as stated. For scrubbing technology selection, we'll be comparing two different processes, Raman-Lott process being the regenerative one, and ammonia-based FGD being the non-regenerative process. However, we have decided to choose ammonia-based FGD because it has cheaper reactant as well as it being an easier process as it only contains one absorber and it can directly produce our VAP. The overall process is as shown in the PFD. It starts off with the SO2 absorber, the ammonium sulfate reactor, the CO2 absorber, the CO2 regenerative column, the methanol reactor, and also the distillation column. The process conditions for the respective equipments are as listed. For plant capacity, our feed consumption of ammonia solution and hydrogen, as well as our production of ammonium sulfate, methanol, and syngas is as shown, leaving our plant capacity to generate ammonium sulfate of 88,000 tons per year and methanol of 272,000 tons per year.
Now I will talk about the heat integration. Basically, we have 9 hot streams and 2 cold streams, and the delta T minimum is fixed at 10 degrees Celsius. After heat integration, the utility reduction of overall duty is 30.49%, and we total save 6.56 USD million per year for both hot and cold duty. This is the PFD of heat integration.
Process control and instrumentation. Industrial instrumentation is the field that studies, develops, and applying measuring and controlling instruments in industrial processes. This is done to ensure safety, product specification, environmental regulations, and economics and stability of the plant operation. The main control strategies implemented in this project are feedback control in the condenser, selective control in the methanol reactor, ratio control at the inlet streams of the CO2 absorption column, and cascade control in the bottom part of the CO2 absorption column.
So moving on to the safety and loss prevention. So for the heads up, we did heads up study at the inlet of the methanol reactor. First, we need to identify the parameters such as flow, temperature, and pressure, and then proceed with the guide words. We need to list the guide words such as no, less, and more, and then proceed with the deviation such as no flow of carbon dioxide and hydrogen to the methanol reactor. And then we need to identify the possible causes such as maybe there is a blockage of a mixture of carbon dioxide and hydrogen pipeline, and then we need to think of the consequences. So there might be no supply of carbon dioxide and hydrogen to the reactor. And lastly is we need to take actions. So we need to install flow control valve, and these steps are repeated for each parameters. For the plant layout, we divided into two areas, which are the non-process area and also the process area. So for the process area, we have 4 plants, which are the SO2 absorption, CO2 absorption, ammonium sulfate production, and also methanol production. At the right side, we have the wastewater treatment, utilities, the expansion area, and also the flare. So the bottom right, we have the storage tanks, and for the non-process area, we have the essential services such as the clinic, the toilets, cafe, office for the workers.
The topic that I'm going to discuss is about waste treatment. There's actually 3 types of waste, which is solid waste, liquid waste, and gas waste. In this project, there's no solid waste except for the municipal solid waste, which is at non-process area. Next is liquid waste, water, methanol, and ammonia. And for gas waste, we have hydrogen, methanol, and carbon dioxide. Next, I'm going to discuss about the gas waste management. For gas waste management, we have 5 types of treatment, which is settling chambers, filters, electrostatic absorption, and adsorption. The method that we have chosen is the filters because hydrogen holds the highest composition at waste, but since the concentration is low, it does not affect the environment when purging.
There are 6 different levels of wastewater treatment, namely preliminary treatment, primary treatment, secondary treatment, tertiary treatment, sludge treatment, and the final discharge sump. Preliminary treatment is done to normalize the flow rate, to minimize pH fluctuations, and to shield biological systems, and also to prevent clogging. Primary treatment is done by pH correction, chemical coagulation, and flocculation. Secondary treatment is done by using holding and stabilization ponds, and the goal is to reduce biological oxygen demand in the water. Tertiary treatment is done to remove specific pollutants such as non-biodegradable materials and heavy metals, and it will be done by using a filter. Sludge treatment consists of removing water in the sludge in order to minimize the weight of the sludge. And the final discharge sump is the last point where the wastewater will stay before being discharged to the environment. It is a tank-like structure that has a large diameter pipe that will drain the water to the sea with the aid of a pump. In the discharge sump, there are pH and temperature sensors, and the wastewater will only be discharged after the parameters are complying with the regulations. So the wastewater will come from plant 1, 2, and 3, and will go through all these unit operations until the final discharge sump, where it will be discharged to the environment only if the parameters are complying with the regulations.
So for ethical and statutory requirements for solid, liquid, and gas waste, we have 3 main regulations, which are the Environmental Quality Clean Air Regulations 1978, Environmental Quality Schedule Waste Regulation 1989, and also Environmental Quality Sewage and Industrial Effluents Regulation 1979. So for solid waste, we have hazardous waste, which is a waste that falls in the list of first schedule of the Environmental Quality Schedule Waste Regulations. And the example of hazardous waste is medicine, petrol storage, metal finishing that has toxic material. So for liquid waste needs to meet with the Environmental Quality Act 1974. And there are 2 standards, which are the Standard A and Standard B, that industries need to comply with depending on the location of the industries under these regulations. So these are the table of the Standard A and Standard B that industries need to refer to before emitting their liquid waste. So for gaseous waste, industries that wants to emit any gases or air emission need to first comply with the air emission standards, which are Start Gas Emission Standard from Environmental Quality Clean Air Regulation 1978, and also recommended Malaysian Air Quality Guidelines Ambient Standards.
Now I will talk about the process economy and cost estimation. Firstly, capital investment is divided into 2 categories, which are capital expenditure, CAPEX, and operational expenditure, OPEX. These are the formula used for CAPEX calculation, where physical plant cost is purchase equipment cost times with summation of direct cost factor 1 to 9 plus 1. Fixed capital investment is multiply of purchase equipment cost and indirect cost factor 10 to 12 plus 1. After that, summation of fixed capital investment and working capital is the CAPEX. Lastly, times CAPEX with 115%. According to reference, 3 to 15% accuracy range should be included to obtain the actual CAPEX cost. After calculation, the actual CAPEX cost is USD 101.43 million. The OPEX is calculated by using this formula, where variable operating cost is raw material plus utility, and the total direct cost is summation of variable operating cost plus with fixed cost, and OPEX is the total direct cost plus with indirect operating cost. After calculation, the OPEX is USD 187.34 million. And lastly, the gross earning is USD 91.14 million.
Profitability analysis will be conducted based on 4 criteria: cash flow diagram, payback return, return on investment, and net present worth. But prior to that, we'll have several key assumptions as listed. We begin to plot the cash flow diagram with the key assumptions, starting from capital investment, sales, total annual expenses, depreciation, income, net profit, income tax, net profit after tax, net cash flow, and finally cumulative net cash flow. At the end of year 4, we can notice that there's a positive cumulative net cash flow. This brings us to our payback return and ROI. In the graph above, we can notice that the break-even point is at end of year 4, as shown earlier. So this gives us US dollars of 383,71880, and we also obtain our ROI percent based on the equation as shown, which gives us 52.6%. A more accurate analysis would be net present worth, which means we discount the values back to EOY 0, bringing it all to a current present value. So this gives us another graph which shows us a break-even point of EOY 5 with the value as such. And our internal rate of return is also calculated to be 26% using Excel, which is far greater than our MARR at only 20%. And thus, by the end of 15 years, we can generate US dollars of 285.81 million.
Now let's see the conclusion. In conclusion, we have 3 main processes, which is SO2 and CO2 recovery using ammonia hydroxide and methanol production using direct hydrogenation. Next, waste treatment has been considered in this project. Since there's no solid waste, then there's no solid waste treatment needed for this project. Next, for gas, the waste treatment was chosen as filters, and for liquid waste, the treatment is preliminary, primary, secondary, and tertiary. Next, for the economically feasible, our gross earning would be USD 91.14 million per annum, and the break-even point at end of year 5 would be USD 21.5 million, and return of investment would be 52.6%. It would generate up to USD 285.81 million by 15 years. Next, for this is the concentrations set by the Clean Air Regulations 2014 for the pollutants. And since the carbon monoxide exceed the concentration limit of CAR 2014, it would be further sent to be flat before releasing it to the atmosphere. Thank you.